guys, welcome back to chapter 4. In this video, we are going to get a little bit more complex with our Lewis structures, so adding in multiple bonds. We're also going to learn about something called diatomics. It's kind of a random place for the textbook to put this in, but we're going to kind of put it in anyway and then use it to talk about double bonds. So, diatomics. Diatomics are going to be atoms that exist as pairs or as partners. For these diatomics, you will not see the atoms just exist by themselves. They will always be in a pair or partnered up. There are 7 diatomics that we just need to know or have memorized. I tried to come up with a cute way to remember diatomics, and it worked really, really well until it didn't. So here is our 7 diatomic molecules. So remember, these guys just exist as partners or as pairs. So the 7 diatomics, in the silly way that I had to remember them, I was like, okay, so there's 7 diatomics. The diatomics start on the 7th element, which is nitrogen. Awesome. That's great. 7, 7. And then they kind of create a 7 on the periodic table. So we go nitrogen, oxygen, fluorine, and then we start to go down the the halogens, and chlorine, fluorine, bromine. So that was really cool. It started on element 7 and it created the number 7 in the periodic table. Except that was only 6 atoms. And then we have hydrogen. So hydrogen kind of foiled all of that, and ruined our 7. But the 7 diatomics are nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then hydrogen. So when we see these elements in nature, we will not just see hydrogen by itself. It doesn't hang out that way. Instead, in nature, we find hydrogen as H2 or bromine as Br2. We would just never see these just by themselves alone. Okay. So knowing this, we're going to practice some Lewis structures of these diatomics. So we know they exist as partners. Let's see what they look like. So the first one is chlorine. So I want to draw the Lewis structure for chlorine. So chlorine is in the 17th or 7A. It's got 7 valence electrons, and there are 2 of them. So we have 14 valence electrons for our picture. With these doubles, there's not really any way to arrange them other than put them next to each other. I'm going to start distributing electrons. I start with the bonding pair, 1, 2. And then I'm just going to keep putting lone pairs until I run out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We go back and check that everybody is happy. So chlorine on the left is touching 2, 4, 6, 8. He's good. Chlorine on the right is touching 2, 4, 6, 8. He's good. So that is our Lewis structure for chlorine. Let's continue on. So we know oxygen exists as a diatomic. So oxygen is in group 16 or 6A. So oxygen has 6 valence electrons. There are 2 of them, so we have 12 electrons at the party. Draw the skeletal structure. There's really only one way to do that, right next to each other. Start with bonding group, 1, 2, and then lone pairs until I run out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can't put any more electrons on the paper. That's all I have. So let's double check. Oxygen on the left is touching 2, 4, 6, 8. Oxygen on the right is touching 2, 4, 6. He's not happy. So the whole purpose of this bonding exercise is to touch 8 electrons. If we're not touching 8, we are not satisfied. So For this one, we're going to finally get to that last step, step number 5. If we have distributed all of the electrons and somebody's octet is not fulfilled, we will explore what we call double and triple bonds. So we will take from somebody that is happy, and instead of this pair being a lone pair that he touches by himself, he says, you know what? Why don't we share these 2 electrons? Let's make another bonding group. So to do that, we're going to draw another line in the middle. Make sure we erase these because we moved them. So now if we look at our total number of electrons, we still have 2, 4, 6, 8, 10, 12 on the paper. So we've used all the electrons that we're supposed to. We look at the one that was happy to begin with. He's still touching 2, 4, 6, 8. So he's still touching 8. Now this guy on the right is touching 2, 4, 6, 8. So now he is happy. So this is what we call a double bond. In that double bond, these 2 atoms are sharing 4 electrons instead of just 2. And we depict double bonds with 2 lines. So knowing this information, why don't you see if you can draw the Lewis structure for nitrogen? All right, so we know nitrogen is in the 15th or 5A. He's got 5 valence electrons. There's 2 of them, so we've got 10 valence electrons at the party. All right, so only way to draw it is next to each other. Start with bonding pair and then distribute. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're done. That's all we have. Okay. Clearly this nitrogen on the right is not touching enough electrons. He's touching 4. So we can explore some double bonds here. So I'm going to take from somebody that is happy, and we're going to throw them into a double bond. So we're just going to rearrange them. Now we look at this hydrogen on the left. He's still touching 2, 4, 6, 8. Nitrogen on the right is touching 2, 4, 6. Better, but we're still not there. So we can explore one more. We can take another lone pair from somebody that's happy, and we can throw them into a bonding pair as well. So move those electrons. Now we go back and check. How many electrons are on the paper? We've moved a lot of stuff around, so let's make sure we still have 10. So 2, 4, 6, 8, 10. So we still have the appropriate amount. Nitrogen on the left is touching 2, 4, 6, 8. So he's good. And now nitrogen on the right is touching 2, 4, 6, 8. And he's good. So in this scenario, we have what's called a triple bond. So a triple bond is that these 2 nitrogens are sharing 6 electrons. So that's our introduction to diatomics, something you're just going to have to know, memorize. And then also your introduction to multiple bonds. How do we handle when octets are not full? I hope you guys found this helpful.